Hi, everyone. My name is Tim Henricks. I'm the CTO and co-founder at Styra and one of the co-creators of the Open Policy Agent project. Today, I'm going to be talking about microservice authorization using Opa and Kuma. So let's get started. All right, so what I wanted to start out with was really this question of what is authorization to begin with. And really authorization is a problem of you've got end users and they're trying to take action on software. Maybe it's Alice trying to withdraw money from an account, or maybe even it's a machine or a piece of software that's trying to perform an action on another piece of software. Like maybe one service, maybe 456 is trying to request invoices from another service. Both of those are kinds of authorization, right? At the end of the day, what we're doing is we're controlling with authorization which actors, whether they're people or machines, what actions can they perform. And this is very different, of course, from authentication, which is often confused with authorization. Remember that authentication is a problem of who are you? How do you convince the software that you are who you say you are? So usually that's solved with usernames, passwords, thumbprints, multi-factor authentication and the like. So today we're going to be focused on authorization and we're going to be looking at ways of implementing authorization that handle both the end user, the people authorization, as well as the service level or machine authorization. So one of the reasons to have this talk is that there's so much interest now around microservice architectures for building applications. And so these microservice architectures are having quite a bit of impact in terms of how you implement and solve that authorization problem. So if you think about the comparison of a monolithic application and a microservice application, the key thing to keep in mind is that obviously in a microservice application, you have many more components that make up that application. And so, I'd say roughly maybe 10x more components. And so what that means if you think about this from a security point of view, is that effectively you've got 10x the surface area to protect. And so in the old world, in the monolithic world, I think what a lot of folks did was they would put authorization, or more generally security control, sort of at the edge, at the perimeter. But in this microservice world, that's no longer sufficient. You don't want to just put security controls at the perimeter. You don't just want to put security controls sort of at the edge of that white boundary that you see on the right-hand side. And the reason for that is that imagine you're an attacker and you imagine that you compromise, the weakest link, which is always what happens. The attacker always compromises that weakest link. Now, if you land on one of those internal nodes, suddenly you've got a whole plethora of APIs, of internal APIs that you have access to that were designed to be used to expose the functionality of those other microservices. And so from a security point of view, what you need to ensure is that those authorization policies that maybe you could enforce at the edge, that maybe you could in the past enforce at the perimeter, are now enforced at the microservice level. What you want is for security to follow those microservices, so that if you deploy a microservice in one of a dozen different places, like is so often the case today, that the security follows it, and that the security of that microservice is not dependent on the environment into which it's deployed. And so that's really the big shift that we see when we start thinking about microservice authorization, is that that authorization needs to be enforced at the microservice level, at the service level, at the internal microservice level, not just at the API gateway level. Now, if you think about the application, certainly it's in the microservice world, certainly it's broken into a whole bunch of components, but it's also still useful to think about the major responsibilities of each of those different microservices. So we've still got gateway functionality and front-end functionality, back-end and database functionality. It's just that we may have many more kinds of those than we used to in the past. And if you think about authorization, really authorization is something that all of those different kinds of services need to think about and handle. So if you think about the gateway is a terrific place to put authorization controls in place for like your public APIs, for the APIs that your end users are going to be using. But if you think about the backend services, we've already articulated why it's important to put authorization at the backend services as well. And there are a couple of things you can do. One of which is that all the ingress, all the incoming APIs to any of those backend services, those are things that you need to exert authorization controls over. But also, if you think about the ability for those backend services to send data to outside services, you do also want to think about putting authorization in place on those egress APIs as well, for the simple reason that it's a good way of of mitigating data exfiltration problems. The front end also needs in some way, shape, or form those authorization policies. Why? Because the front end is responsible for providing a good and smooth user experience. And so if that front end is, for example, showing a list of invoices or pets or whatever the application was designed to do, often what we see is that list of resources has little action items, action buttons next to them. Maybe it's a trash can if the user, to let the user delete that resource, or maybe it's an inspector icon to let the user look at the details of that resource. And so the front end needs to know, ideally, whether or not the user can even delete the resource or can inspect the details of that resource. And so the front end also needs to know at some level what that authorization policy is. It's not enforcing it from a security point of view, rather it's just enforcing it for a usability point of view. And then even the backend databases. Sometimes the databases are going to be storing information that's relevant to making authorization decisions. Like, for example, who is the owner of a resource? Maybe the authorization policy says that only the owner of a resource can delete it. Well, the database is the place where that ownership information is often stored. But thinking of it slightly differently, the database is also another point at which you could or should implement authorization controls. So again, if you think about the application sort of holistically, what you see is that authorization is used sort of throughout that application stack. Today, what I want to spend a little bit of time on is looking at back-end authorization, because this is sort of the newest piece of all this. Authorization has always been used throughout the application, but enforcing it at the back-end service level is what's new and what we'll spend a little time on. So let's look at a few different architectural choices for how you can go ahead and enforce authorization on your back-end services. One of which is to simply hard code those authorization policies within the service. The idea here being that the microservice, anytime it receives an API call, can go ahead and run some piece of code that implements that authorization policy within the microservice itself. So if the microservice is written in Java, then the authorization policy is a function written in Java as well. So there's some benefits to doing it this way. One of which is that it's very performant. You're just running more Java code, for example, and so you can make that as performant as you want. It also gives the application developer complete control over how and when that authorization policy is implemented and how it's deployed. There are a number of drawbacks, however. Obviously, if you're implementing authorization policies in each and every microservice, you may end up repeating yourself. You may end up re-implementing it over and over. You can also end up with, because of that, inconsistently implemented policies. So maybe, if you think about the policy that you want to put in place, you look at the wiki or the PDF, it's not necessarily the case that policy is what's actually implemented in those individual services. If you think about enforcement, well, we're sort of relying on the microservice developer to go ahead and run those authorization policies and enforce them appropriately. That may not happen simply because we've done it so many times. Security reviews are going to potentially be quite slow, right? Why? Because now you've got a bunch of Java code that you need to point your security teams at, and they need to pick through that, try to understand what the policies are saying, and also understand when they're enforced and when they're not. There's no real way to hot patch these authorization policies that are embedded within microservices without obviously redeploying the microservice itself. And then here's an interesting one that I heard talking to a few CISOs, which was that, if you zoom out of a single microservice and you start thinking about all the applications across an organization, well, the CISO's job is to look at and try to understand what's going on. And if there's a security breach, they need to be able to detect it. And so when they're looking at, if you had 50 different teams developing microservices, if every one of those teams implements authorization themselves, then what you're going to end up with is 50 different variations on logging messages that say there's an unauthorized access going on. And from the perspective of setting up a SIM to actually detect those kinds of attacks, now that, when you're authoring the SIM, you've got to take into account all those 50 variations of logging. So anyway. All right, so this is one option. There are benefits, there are drawbacks. One way to look at and address some of those drawbacks is to do the sort of usual thing in a microservice architecture, which is to decouple that authorization policy from the individual microservices and provide basically a dedicated microservice that's responsible for making authorization decisions. This obviously solves a number of the problems around repeated work and inconsistency, because you have a dedicated microservice that makes all these decisions. The sort of drawback to this, though, and it's a pretty substantial drawback in many settings, And that is that the availability and performance takes a real hit here, right? Because at the end of the day, when one of these microservices, now every time it receives an API call, it's got to make another API call. It's got to hop over the network again in order to get an authorization decision, and then go ahead and enforce that. And so this kind of availability and performance is really problematic in a microservice architecture, because instead of a couple of network hops like you might have in the monolith, maybe you have 5 or 10 network hops that you're running in order to serve an end user request. And if you have this sort of authorization architecture, then what you're literally doing is doubling the number of network hops that is required to service an end user request. And in many microservice architectures, that's just an availability and performance hit that's unacceptable. One obvious way of addressing that problem is to distribute authorization. So instead of having one service that is centralized, that is dedicated to authorization, you sort of implement a distributed version of that authorization service. So the key difference here is that even though these authorization components are running on the same server as that microservice, so sort of think sidecar model here, it is nevertheless still decoupled from the underlying service, just like in the centralized version. This has the nice benefit that because this authorization service is running on the same server as that microservice, the availability and performance is roughly the same as the hard-coded version over here on the left. Yet at the same time, you get many of the benefits that you had from the centralized service. There are a couple of still drawbacks to this, one of which is that now we're still relying on that microservice author to go ahead and explicitly change their code and make a request to that authorization, that external authorization service. So that would bring to rise the sort of fourth version here. The fourth version of this architecturally is that we use a service mesh or a network proxy. And the idea here is that at least conceptually, you put a wrapper around that microservice that is responsible for handling all the requests to and from that microservice. And then what you do is you integrate that service mesh with the external authorization service. And when you do that, obviously now, the microservice author doesn't need to change their microservice. And what you're also guaranteed is the fact that each and every request that goes to and from the microservice is necessarily enforced, has authorization policy enforced by it, because you're doing the integration at the service mesh or the network proxy level. So the interesting thing to me is that while these may seem at first blush to all be distinct choices and you have to pick one of them, in actuality, what we see people doing is really picking one or more of them. And so there are cases where there are pieces of what some people might call the authorization policy that just by its nature is natural to implement in the microservice. Some of the other authorization decisions may need to be, are more natural to sort of externalize and decouple. And then whether you pick a distributed or a centralized service, that sort of also depends on the characteristics of the application and the organization that is building it. What we're going to do here is zoom in again a little bit on the service mesh option. This is probably the most recent one. And so it's a good one to sort of look at and dig into a little more deeply. So here, one way to go ahead and implement this sort of service mesh-based version of authorization is to use things like Kuma and Open Policy Agent. So Kuma, I think most of the folks here would already know what Kuma is, but I think of it as a service mesh. It's got two components. It's got a data plane. That data plane is shown here, runs on the same server as every microservice. That Kuma data plane is really a network proxy. It's responsible for sending and receiving all the traffic to and from that microservice. Open Policy Agent is a cloud native computing foundation project. It was designed fundamentally to go ahead and allow you to decouple authorization from a wide array of different kinds of services. So we can certainly use it here to decouple policy from this microservice. So the way that this would work is that the Kuma data plane as well as Open Policy Agent, think of them as both running effectively as sidecars next to the microservice. The way you would set up, and all these are running on the same server. So the way you'd set this up is you would maybe at the IP tables level configure it so that all the network requests are routed through Kuma. And so anytime Kuma receives a network request, it goes ahead and it sort of sends an authorization query over to the Open Policy Agent project. OPA goes ahead and returns an authorization decision to Kuma. If OPA decides to deny the request, then Kuma might return a 403 or drop it on the floor or whatever it's configured to do. If, on the other hand, Opa decides that the request is allowed, then Kuma will go ahead and send that request there in step 4 over to the microservice, where the microservice can handle it the way it always would, return a response, and again, Kuma would then send that response back out to the caller. So this is one very clean and simple way of implementing service mesh level authorization. We'll see a demo of this in a little bit. Now, once you've put that in place architecturally, what does it allow you to do? Well, so one of the things it allows you to do is now put policy examples or authorization policy examples in place using Opa's language. And that language allows you to implement all kinds of different policies. So remember at the very beginning, we talked about service level authorization versus user level authorization, right? And so, one of the questions that comes up is, well, like, what do both of those look like once you've got something like this service mesh level authorization in place? And so here, I won't go through all the details, but I'll show you just at a high level what's happening. So the idea here is that the policies you're writing, at least with Opa, these are all very simple if statements that you're writing. So the first one here on the left is illustrating how you might put in place a service level authorization policy. The statement here is saying, allow the request if all of these conditions below hold. And so input is sort of the keyword that you use with Opa that stores that whatever input is handed to Opa. And so what we're doing here is we're checking if the method is a get and the path is, well, whatever that application is that's meaningful to it. So /pets if it's a pet store application. And then for service level authorization policies, you're also handed, when you're using Kuma, things like the source and the destination headers that came along for HTTP. And so you can use those as well as whatever other information that comes along and is handed over to Opa to make authorization decisions. And so in this case, we're allowing service A to talk to service B using the API get on /pets. Now, if you think about user level policies, really the machinery is all the same. The only difference is what conditions are you putting into that policy? So if in this particular case, we wanted to allow all customers to run the get method on /pets, then here, again, we're just checking the method, the path, but this time, instead of looking at the headers, we're gonna look at the token, like the user, like often this is a JOT or a JSON web token that stores, attributes about the user. That's actually making a request. And so here we see a user level policy. And what I'll call out here is that really the distinction between these is very slight. It's only, the distinction boils down to really just what conditions you put into these rules. I won't go into the details on the one on the right, but the other thing that I'll call out here about what you can do once you put Opa and Kuma in place is that you can use Opa's ability to make decisions based on external data as well. So certainly it's the case that that these two examples have basically just used the information that's included in the headers of let's say the HTTP request. But Opa does allow you to make to inject additional external kinds of data and then to use that data in order to make decisions. So maybe you need to know maybe only the owner of a resource is allowed to delete it. Well, who is the owner of the resource, right? That's not going to come across on the wire in the HTTP protocol. Maybe that's something that has to be fetched out of the database and then handed over, in this case, to Opa in order to make a decision. And so Opa does allow you to do that, and there are a number of different ways to make that possible. Now, if we take a step back, what we've seen and focused on for the last little bit is how we can use and how we can implement authorization at the backend microservice level. And that was great. But if you remember, really authorization is something that many of the different components within the application do care about. And so, at the gateway level, maybe you're using Kong as the gateway. One of the nice things about using Opa for authorization is that it was designed to work not just with Kuma, it was designed to work with really any sort of cloud native piece of software. Its mission in life is to decouple policy from the underlying software, and so it will work with many different pieces of software. So what you can do, and what some folks have done, is integrated Opa with Kong, just like I articulated how Opa can be integrated with Kuma. We've also seen people using Opa connected to the front end to go ahead and have the front end ask, hey, tell me all the permissions this particular user has, and then use that information to go ahead and render the front end appropriately. We've seen people using OPA to enforce authorization, specifically with Kafka databases. That's a pretty popular use case. And there are a couple of other sort of early use cases for using OPA to enforce authorization at the database level as well. So the key takeaway here is that thinking about authorization, if that's the problem you're trying to solve, you need to think about it at multiple levels of the application stack. And what we're seeing, obviously I come from the OPA world, what we're seeing is that using OPA to help with that has helped a bunch of folks. Now, the question then becomes, we often get this one, which is, well, okay, so great. We've said OPA works with all these different kinds of software. Well, how does that work? Give me a quick overview. And so the way that OPA works is that it was designed to work really with any service. And so here we used to have Kuma in the picture. Now we just have a generic service. That service could be Kuma or Kong. It could be the Kubernetes API server. It could be maybe a CI/CD pipeline that's running Terraform scripts. It could be Kafka, and so on and so forth. The idea being that that service at some point in time decides it needs an authorization decision. And so it goes ahead and sends OPA a policy query. OPA returns that decision to the service, and it's the service's responsibility to enforce the decision. Obviously, it's OPA's responsibility to make the decision. Now, the key thing that enables OPA to work with so many different pieces of software is that that policy query can really be any arbitrary JSON object. So the idea is that OPA does not know anything inherently about HTTP methods, the method, the user, the path. It does not know anything inherently about Kubernetes pods or ingresses. It does not know anything inherently about Kafka topics. However, I, as a policy author, I understand what all those things mean. When the service hands over a chunk of JSON and that JSON has a method, a user, and a path, well, I know it's intended for a Kuma policy decision making, and so I can write the policy that's appropriate to make the correct decision. When the service hands over some JSON that represents a Kubernetes ingress, well, I, again, as a policy author, know exactly what an ingress means, what the different configuration options are and should be, and so I can write the appropriate policy. So that kind of flexibility with OPA has led, people use this all the time, and what that allows them to be is pretty creative in terms of what that interface between the service and OPA actually is. The other thing I'll call out that I mentioned briefly a moment ago is that OPA was designed to allow you to write what we like to call context-aware policies. And for us, what that means is that you can inject arbitrary external data into OPA that represents the state of the world. And that state of the world can then influence whatever policy decisions are made. So the example I always like is to use one around PagerDuty, which is, let's imagine that you want to write a policy that says only employees in the organization who are on call can go ahead and run, read-only requests on production APIs. Well, who's on call? The microservices don't know who's on call. Your LDAP typically doesn't know who's on call. Usually on call is stored in a third-party service like PagerDuty. So what you can do with OPA is extract that data out of PagerDuty and inject it as JSON into OPA. And once you do that, now OPA has that additional information, and you as a policy author can choose to use that information as you see fit. The last thing I'll mention on this slide is that the policy decisions OPA makes can be arbitrary JSON. And that's beneficial because in addition to being able to make simply allow and deny decisions, it allows OPA to be able to do things like, for example, return the list of new headers that, for example, Kuma might need to inject into the HTTP request before it forwards it onto the end service. So what we like to say is that OPA is a general purpose policy engine. It was designed to decouple policy decision making from policy enforcement. So definitely check it out if you haven't seen it already. We can take a step back even further. We've already talked about this. This is the picture we always like to show folks for the first time they see OPA, and that is that OPA can be used across the stack. So not just within the application, as we sort of described, but that application is often running on, let's say, Kubernetes. Using OPA for Kubernetes authorization is a very popular use case. Maybe that Kubernetes cluster is running on a public cloud. Using OPA to put authorization policies in place over Terraform changes is another popular use case. Maybe you're going even further and thinking about putting authorization policies in place in a CI/CD pipeline. Again, another very popular use case for OPA. So here is this picture. All the different classes of use cases that are sort of depicted here are things that folks are using OPA for in production at scale today. One of the things that does come up then once you've put OPA in place, maybe across many different use cases, or maybe within your application and many different components, or even within even within the service mesh within for your backend services. At the end of the day, what you end up with is a number of different OPAs. I always like to say that if you've got 500 backend microservices, then when you're running OPA as a sidecar, you end up with 500 instances of OPA. If you think about deploying OPA for other use cases, you'll have even more instances of OPA. And so the problem at that point that you need to solve is, how do you manage all those OPAs? How do you know that they're healthy? How do you distribute policy to them? How do you record the decisions they're making, and so on? So in addition to having created OPA and donated it to the Cloud Native Computing Foundation, Styra created a second piece of software, which we like to call the Declarative Authorization Service, or DAS for short. Its mission in life is to provide that control plane, or that management plane, that single pane of glass for OPA, for regardless which use case you're using it for. So when I go through the demo briefly here, I'll go ahead and show you that. OPA and all these other Kong, Kuma, all these other open source projects, they work wonderfully together. I always like to think that they would just work better with Styra's control plane. So when we look at the demo, we're going to go back and I'm going to show you this working example of how you can connect Kuma and the policy agent and use that to implement authorization across your microservice application. Okay, so, all right, so to do this demo, we're going to start with, this is Kuma's sample application. So I'm running this on Kubernetes. I'll show you that momentarily. But here is the application. It looks quite nice, I gotta say. And so what's happening here is that anytime you load the page and anytime you hit this read reviews button, or any of the buttons, that's issuing a backend request, API request to the backend services. And so what we did, in addition to just running this application, we went ahead and added, we're running on Kubernetes. So here's one of the deployments on Kubernetes. What we did was we went ahead and added to each of these backend services a sidecar, OPA as a sidecar. And so here we're just going ahead and grabbing the upstream version of OPA, and then we've configured it to go ahead and talk to the Styra DAS, as I mentioned. But the idea is that once you drop that OPA in place and you run it, we're also using Kuma's proxy template to go ahead and configure all of the Kumas to send requests that it receives using the external authorization filter to OPA, and then to do the appropriate thing with the response. So I won't go through details there, but those are the only two things that we needed to do for adding OPA to the sample Kuma application. All right, so everything in this application seems to be working fine. As we click read reviews, we see some review data come up. So now let's look at sort of what OPA is doing under the hood. Every time OPA receives a request every time OPA receives an authorization request, it is configured to log all of the decisions that it makes, as shown here. So here what you're seeing is there are really two categories of API calls. One is a get on a particular item. This is getting that extra data. And then there's a second get on the list of all items. And so what you can see here, if you kind of scroll through these decisions, is that sometimes they're allowed, sometimes they're denied. And these decisions are pretty powerful. So if you really wanted to see, how we talked about OPA receiving input from Kuma, a policy query from Kuma, if you wanted to see exactly what that information looks like, you can open up this file and sort of peruse the different parameters that you have access to. So here's a source. Here is the HTTP request, and within the HTTP request, you see a method and a path. There's a destination up here as well. And so whatever information that Kuma hands over, you can inspect it here. The other thing that I wanted to show quickly was that you can put policies in place that not only sort of observe and monitor the API calls that are being run, but that also control them. And so here what you see is the policy. This is the actual OPA policy that it's enforcing right now in the application. There are 2 allow statements. We kind of talked through these a little bit. They're doing what you would expect. Here's a get on /items that's being allowed. And here's a get on the more refined get /items on an ID, and then asking for the reviews. And so right now we're allowing both of these. Let's suppose just, we wouldn't actually do this in production, but let's just to show you that this is all working, we'll go ahead and comment this thing out. We could go ahead and publish it and have OPA start enforcing it right away. But before we do that, I'll go ahead and hit this validate button. Before you make changes to policy, one of the nice things that OPA allows you to do is sort of dry run those policies in a CI pipeline or wherever, to get a sense as to what changes or what impact that policy would have if you put it into production. And so over here on the right-hand side, as part of the Styra DAS, we do take that log of decisions and we actually just rerun them, historically speaking, over your new draft policy and identify all those changes to decisions that have been made in the past. So here we've removed this allow statement. So what we see here is a bunch of new denies. And so I, as a policy author, before I put a policy in place, could use that kind of functionality to decide whether or not it's safe to put that policy change in place. So let's go ahead and publish it. Now what's happening when we hit that publish button is that OPA is configured to periodically pull down the latest policies and then to start enforcing them. And so it'll go through a compile stage and activation. It'll sanity check and make sure that everything looks good before it goes ahead and starts enforcing them. But now let's take a look and see if it's gotten an update. So the good news is here that I could refresh that page, and remember that page was running a backend list call. So we know that that is still allowed. But what we see here is when I click the review button, now we get this 403. And so what that means is that OPA has rejected that request. And that's exactly what we would hope. So obviously what we're seeing here is the fact that this application didn't change. I didn't have to redeploy it on Kubernetes at all. But at the same time, I could dynamically hot patch those policies for whatever reason I care to. Okay, so I think that's gonna do it for me. So thank you all for giving me some of your time. Please go ahead and check us out online if you've liked some of what you heard. We've got plenty of folks who would love to chat and help you out if you're interested in like service mesh level authorization or application authorization more generally. So there are definitely Slack channels for OPA and Kuma, I know. So that's a great place to engage if you so desire. And with that, I think we will just open it up for questions and answers.